Good morning, y'all. We're gonna take another step. We're gonna look at graphing logarithmic functions. As we graph logarithmic functions, they pretty much have the same basis as the graphing the exponential functions. There are a couple of small changes we'll have to make in respect to the range, in respect to the asymptote, and so just be aware of those. Just remember though, whenever we were graphing we're graphing exponential functions, your graphs traditionally traveled horizontally. So you either had a graph that was going this way the whole time. Now when you're graphing log functions, your graphs are going to go up and down now, alright? So that changes the domain and the range as well as the asymptote. So you got to be aware of that, okay? So let's take a first look at just the steps for graphing log functions. You got to find the x and your y-intercept just like we did when we were doing exponential functions. To find the x-intercept, you substitute 0 for y, and then you solve. And then to find your y-intercept, you substitute x for 0, and then you solve. I'm going to pause for a quick second just to say this. If you guys have any questions about what's going on, there are two ways to really leave the questions for me to answer. The first one, I would like for you to go to the parking lot. And when I say go to the parking lot, that simply means take a Post-it note and put it on the board with your question. Now, don't say, I don't know how to do this. Be as specific as you can with your questions. How do I solve logs? How do I graph my asymptote? And I can get back with you that way, or you can post it on Edmodo. And like I said, be specific with your questions. So back to the steps for graphing log functions. Find your x-intercept and your y-intercept. Then you need to find your asymptote. And now remember, finding the asymptote is x equals negative h. Now, remember when we were doing exponentials, the asymptotes ran horizontal. Okay. Now that we're graphing logs, the asymptotes are going to go vertical. So that's a key piece to remember. As also, whenever you're doing more points, complete an input and output table or an XY table, depending on however you call it. And so after you do that, then you gotta know you want to go ahead and plot your graph and trace your graph to see if it's increasing or decreasing. And you get kind of an inkling by looking at the function to see if it's increasing or decreasing by just looking at the terms. If a is negative or if x is negative or if b is a fraction, chances are you have a decreasing graph. If a is positive, or if x is positive, or if your base b is greater than 1, then you might have an increasing graph. So those are key indicators to look at as you're doing this. Don't be afraid to take your time and do this. Make sure you go step by step and just really work this out. So trace the graph. After you plot your points, when you plot your x-intercept, plot your y-intercept, plot your additional points, go ahead and trace the graph to see if it's increasing or decreasing. And remember, increasing or decreasing looks at the graph going from left to right. So after you do that, then you can go ahead and do the domain and the range. And your domain and the range, it helps determine your end behavior. And your end behavior also is good for when you're looking at your graph, just to make sure that you're on the same page. But keep note of this. If you have an increasing graph, you keep the end behavior the same. Domain 1, domain 2, range 1, range 2. But if you have a decreasing graph, make sure you flip the range, okay? So we're going to look at our first example. We have y equals log base 3 of x plus 2. Y equals log base 3 of x plus 2. So first thing we got to do is we got to solve for our x-intercept. So what we're going to do, we're going to substitute 0 for y, and then we're going to solve this graph. So we have our original problem, y equals log base 3 of x plus 2. Then what we do is we substituted the 0 in for the y. So now my equation reads 0 equals log base 3 over x plus 2. Now we can apply the circle method or a switch method, as some people call it. And when we apply that, remember now, once we apply that right here, my base 3 right here becomes the base of my exponential function. Because remember, exponential functions and log functions are polar opposites of each other. So we have base 3 right here becomes 3, and we have 0 right here. And so this 0 becomes my exponent, and this 3 right here becomes my base. So when we rewrite it, now we have 3 to the 0 power. So remember, in the circle method, this 3 right here, the base of my log, becomes the base of my exponent. And so now we have 3 to the 0 power equals x plus 2. Now remember, anything raised to the 0 power is going to give you 1. So now we're looking at 1 equals x plus 2, which is cool because we try to keep math as simple as possible sometimes. So now we just subtract 2 from both sides. When we subtract 2 from both sides, now we're left with negative 1 equals x. So this tells me that my x-intercept is going to be negative 1, 0. So that's the first point on my graph. Now we're going to move over here and we're going to look at our y-intercept. So for the y-intercept, we substitute 0 for x, and then we solve it. So we're stuck with our original problem right here. Now what we did here was we plugged in 0 for x right here. So now we have y equals log base 3 of 0 plus 2. Now, when you add the 0 and the 2, you get 2 right here. So now we have y equals log base 3 of 2. Now, what we do here is we use our change of base formula, which is cool. Because with the change of base formula, all we're doing is we're going to get our calculators, and we're going to say log of 2 divided by log of 3. Or as I like to explain it, log big number divided by log small number. So now we have y equals log 2 divided by log 3 sitting right here. So like I said, the big number goes on top, the little number goes on the bottom. So now when you put it in your calculator and you divide it out, you have y equals 0.63. So now I have an x-intercept of negative 1, 0. Now I have a y-intercept of 0, 0.63. So I already have 2 points here on my graph. Like I said, if you have any questions, feel free to write your questions down, post-it notes, postcards, whatever, and put it on the parking lot, on the board, parking lot. And I'll look at it, and I try to answer your questions as best of my ability. If you can't do that, you can log onto the Emoto and post your questions there. So next thing is our asymptote. Remember, the asymptote is y equals negative h. So if I look at my original problem right here, my value for h is 2. So my value for h here is 2, so I need the negative of h, or the opposite of h. And so my asymptote is x equals negative 2. So now I can look at my input-output table. As you can see, all I'm doing here is I'm using, and you can look at your asymptote to tell you what numbers you really want to use. All right. So by x being negative 2, that means I know that I can't use negative 2 for my x terms, but by also knowing where my x and my y intercepts were, I know that I'm moving everything. I'm using my graph on the right side of my graph. So I chose numbers that was to the right of negative 2. So here I chose 1 and 2. I could have chose 0, but I've already done that when I found my y-intercept. So now I have x equals 1. So I substituted 1 in here, okay? And so now we have 1 plus 2 gave me 3. So we have log big number divided by log small number, log of 3 divided by log of 3, which is 1. So my first point is 1, 1. So I mean, I have 3 points already, but I'm gonna go ahead and do a fourth right here. We follow the same pattern. Log base 3 of x plus 2. We're going to substitute 2 for x right here. So now we have log base 3 of 2 plus 2. So then we have 2 plus 2 gave me 4. So now I'm looking at log base 4 divided by log base 3. And so when I divide log base 4 divided by log base 3, I get 1.26. So my second additional point is 2, 1.26. So this is how the input-output table works. And this works on a number of things, but it's real good here because now you get to see it step by step how things play out as you're doing the math. So we found our x-intercept, which was negative 1, 0, we found our y-intercept, and now we found our asymptote and our 2 additional points. So now we're going to just look into the graph itself. So here's my coordinate plane, and so this is my first point that's coming up, and that is my x-intercept of -1, 0, and then we have the next point that's coming up, my y-intercept of 0, 0.63. Now my third point is 1, 1, and now I have my fourth point, which was 2, 1.26. So now I have my 4 points, and I really don't have a good line here, but having my asymptote right there tells me that all of that my graph line is going to follow those points right there. And so that's how my graph line will look, freehand sketch, of course. And so now I can look at looking into my domain and range, and since x is positive, I know my domain is going to be -h to infinity, and I also know that my range is going to be all real numbers. So knowing that, I can go ahead and plot my end behavior, and like the note says, since the graph is increasing from left to right, no flip of the range is needed. And so as x approaches -2, f of x approaches -infinity. Let me try to explain that right quick. You see how my graph line is, as it's going towards -2, as my x values go towards -2, my graph is going down towards -infinity. And as my x approaches infinity, my graph goes up toward infinity. That's what that's a good visual picture of how end behavior works. So now my second example is the negative log base 3 of x minus 1 plus 1. Now, look at this thing right here. We have an a right here that's already negative, so this is a good indicator that my graph is going to be a decreasing graph. So I have to flip my range on my end behavior at the end. So x-intercept, we just substituted in 0 for y, and then we're able to add 1 at both sides. We added 1 at both sides, so we now have 1 equals negative log base 3 of x minus 1. So we divide both sides by -1 to get rid of that negative in front of my log. And now, like the note says, multiplying or dividing by -1 to remove the negative from the log. So now I have -1 equals log base 3 x minus 1. So log base 3 x minus 1 equals -1. So now I can take my 3 and use my circle method, my switch method. So now the base of my exponent, the base of my log becomes the base of my exponent. And so we have 3 to the -1 equals x minus what? So going from here, I know going from here, a negative exponent now it moves my number to a fraction. So I have 1/3 equals x minus 1. So if I add 1 to both sides, I have 1 1/3 or 1.33 equals x. So my x-intercept is 1.33 equals 0. Well, I'm gonna stop this video right here, and we're gonna come back with the next video, and we're gonna continue graphing.